Recording started.
Hello everyone and welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. My name is Vanessa Friedman. I'm a biology teacher and an alumni of the new Science Teachers Academy. I will be moderating tonight's program. Joining me from Virginia is Jeff Lehman. Jeff will be available to answer your technical questions during the live program. Today's seminar is titled NES, Engineering Design, Forces in Motion, Balloon Aerodynamics Challenge. Our presenter is Kristy Hill. Thank you, Kristy, so much for being here this evening. It's all up to you.
Well, thank you, Vanessa. Welcome, participants. I'm very glad that you could join us tonight. Like she said, this is Forces in Motion, Balloon Aerodynamic Challenge. And I am Kristy Hill. I'm a NASA Explorer School education specialist from Marshall Space Flight Center, which is in Huntsville, Alabama. I taught middle school science for 12 years and have been with NASA Explorer Schools for nearly 2 years. And so I'm very excited to be joining you today and teaching this class. Now, how many of you have had a chance to look at this lesson before today? We're going to go to the polling types and, okay, there they are. So give me a check or an X whether you have had a chance to look at this lesson. And it looks like most of you have not. Okay, well good, you've come to the right place. This is a fun lesson and it's very easy to do this on multiple levels. I saw that we had elementary teachers all the way up to high school teachers, and this is something that can be geared towards the age and level of your students. So a very good lesson for you to be coming to today. We will be participating in several different parts of this lesson. First of all, I'm going to give you the lesson overview in general, what we're going to be talking about. I'm going to tell you how this relates to NASA and how NASA uses these terms and vocabulary words that you may be using in your classroom. Then we're going to talk about the lesson and specifically how to carry this out in your classroom. And then we'll talk about extensions and modifications that you may want to use in your classroom. For those of you that are NASA Explorer School teachers, you know how to get these lessons. You can get it off the lesson library. Some of you, however, I know are not part of the NASA Explorer School, and so I'm going to put the lesson here into the chat box. If you would like to look it up, you will be able to find out there about it. Okay, the national standards here, this level, it's specifically geared towards 6 through 10, but like I said, I think you can either make this easier for your upper elementary students or a little bit harder for your upper high school students. You'll learn about changes in property and matter, forces in motion, and technological design. The objectives, students will work through the engineering design process. They'll observe the concepts of lift, drag, weight, and thrust with a helium balloon. And they'll demonstrate the concepts of buoyancy and density. Now, first of all, students need to understand the concept of density before beginning this lesson. There are pictures shown here that show different forms of density that you may have already discussed with your students. In the first picture here, we have some different densities of liquids and solids, kind of a classic picture here of different materials and the way that they can float on top of each other because of their different densities. The second picture here, we have density of different due to different temperatures of air. We have a hot air balloon, and of course it rises because it's less dense. And also the density of air in a closed container, and this can be related to temperature or air pressure. So density is defined as mass per unit volume. All right, and so the next slide, in the chat box, which lessons are you covering for density in your classroom? You can just give me a short answer. Okay, I see some people talk about temperature, molecule movement. Okay, they talk about all the ones we just talked about: minerals, liquids, water transportation, gas laws, fluids, property of matter. Okay, so lots of different areas that you may be teaching in your classroom, and so there are different ways that you may be teaching density, and I see that several of you are saying you teach all of these concepts, so that's good. So that's just kind of an overview in general of the terms we're going to talk about. Do you have any questions so far? And I see a couple people chatting, so I'm going to give you just a minute, a few seconds actually. Okay, I don't see any questions coming up, so we're going to go ahead and talk about the NASA connection and how, let's see how density and neutral buoyancy connect to NASA. When might NASA use the concept of density and neutral buoyancy? Put some ideas into the chat box. When might NASA use these concepts? Okay, I see a couple people. And we're going to talk about it. I won't call you out if you're wrong or right. If you want to just make a guess. Landing a rover on Mars, practicing for EVAs, space travel, weather balloons. That's a good one. Okay. Flight. Good. Zero gravity. Oh, here's a long one. Okay, Saturn is less dense. The planet could actually float in water. That's neat. Landing on the moon, food in space, returning the rocket to Earth. Okay, good. Y'all have some great ideas. So we're going to talk about that. Now we have some pictures here, and I'm going to show you a couple of videos today. We talk about neutral buoyancy when we have, at Johnson Space Center, there is a large pool called the Neutral Buoyancy Laboratory, and it's a huge pool where the astronauts put on their spacesuit and they weight it in just such a way so it's very similar to being in outer space, and so they're neutrally buoyant. We also have the space station that we have to keep in orbit, and so there's a little bit of buoyancy with that. So we're going to watch two short videos, and I will show you how to get to these videos later, but this is part of the lesson. The lesson actually encourages you to show these videos to your students. All right, so the first one we're going to watch, and this one is about 2 minutes long. So this should pop up in your screen, pop up as a pop-up browser. If that doesn't happen for you, then I will also have this in the chat box, so you can click on it there. Okay, hopefully you got a chance to see that. We will be watching about 2 or 3 more videos, so if you have your pop-up blocker, I saw Jeff put a note, if you have your pop-up blocker on, you might not be able to see it. You can just click on the link that I put in the chat box, but it should pop up in a separate window when I put that out for you. Okay. So moving on, I'm going to ask you a quick question about that after we watch that video and just a little highlight. So neutral buoyancy, pick the answer, and we'll put the answers up there. Pick the answer that you think is correct. Okay, I see lots of people answering. There is a box up there that you can choose your multiple choice letter. Okay, I see some people putting it in the box. All right, so I'm going to display these answers, so last chance, and I'm going to publish these answers, and then I'm going to tell you what. So most people said C. And the correct answer is C. Yes, neutral buoyancy is a condition in which an object's mass is equal to the mass it displaces in a given medium, or an object that neither floats nor sinks. All right, we are going to watch another short video. This one's only about a minute long. Again, I will put this in a pop-up, so it should pop up on your screen. If it doesn't pop up on your screen pretty quickly, then you can also use this link that I'm putting in the chat box. So I'm going to go ahead and get that started for a pop-up. And all right, so now I have a short question about this one too. Drag is defined as which one of these? So which one of these is the correct statement about drag? Okay, and there should be, you can put your answers at the top, or I see some people putting them in the chat box. Okay, I'm going to display the answers, and it looks like most of you put B, and the next one says yes, B is correct. And I have corrected A and C for you to make those read correctly. So the space station does lose about 90 meters of altitude, and it talked about how those were changed over time and how it is moved. Okay, so we talked about that a little bit. Now another thing, and someone had mentioned this before, is that NASA also has balloons, and they show NASA is using balloons for research. So let's watch a short video, and this is going to be our last video till close to the end, about ballooning. And we'll only watch about the first 2 minutes of this video. So I'm going to send this out like I have been, but when it gets to about 2 minutes, turn it off, and then we'll come back together. There is more to this video, and you may want to see it later, but I think the first 2 minutes will get our point across of generally what NASA does with their ballooning. So again, you can use the chat box, or I will push this out to you. All right, if you have gotten to 2 minutes on that video, then go ahead and click that off. There is more that you can see, but like I said, I think that that hits the main idea of what we're talking about there, and that's something you may want to share with your students when you're doing this lesson. All right, so here are some actual pictures that were taken. This one is in Antarctica. These are some different balloons. This one here was actually taken, it's way up, and this was taken through some type of telescope or viewing. So you see some different images here. This one is just a diagram that's drawn of possibly taking balloons to Mars and being able to see what's going on in Mars from a balloon. All right, so just to highlight some of you that may not have seen the video, these NASA balloons can be inflated and can stand up to 900 feet tall. Some fly up to 25 miles in altitude. Most are helium-filled. They carry instruments to study things such as cosmic rays without the distortion of the atmosphere. And scientists track data with these payloads. So what your students are going to be doing is something similar to this, potentially, is carrying instruments to study things, and you're just simulating this, but that's what you may be doing in your classroom. So let's pause for questions. Does anyone have questions so far on what we have talked about? Okay, I'm not seeing any questions come up, so I'm going to go ahead and move on, and we will start talking about the actual lesson and how you will do this lesson in your classroom. You actually won't be using weather balloons. You'll be using regular balloons, but you're using that to simulate or mock the weather balloons. So I'm not sure where or if you could get those weather balloons. That would be pretty neat if you could. Okay, so those lesson in detail. So let's see how you can carry out a similar experiment in your classroom. In this section, we'll look at the details of the lesson. So the challenge for your students is to design a system to establish a helium balloon floating at different altitudes in the classroom, or a field if you're going to go outdoors. So you're going to try to get them to float at a specific spot. So how do you think you're going to do that? How will the students make it float in a certain spot when they know that if you let a helium balloon go and it doesn't have anything on it, it's going to go up? So you want your students to think about how they're going to do that. And I see some people putting some ideas there. Okay, so you might, depending on the level of your student, you may want to give them hints or just throw it out there and let them figure out by using the materials. So you will have a little bit of preparation time. There is a guide that goes with this. And you'll want to read the guide, gather your materials, test your own design, and set up your classroom for this, or find a place that you may be doing this outside. Now, there are some basic aerodynamic forces, and depending on the level of your student, you probably want to discuss this. Thrust enables a plane to be propelled through the air. An engine turns the propeller, forcing air backwards and creating a thrust that sends the plane forward. Weight, well, that one's simple. That's what we refer to as gravity. A plane must escape Earth's gravitational pull to move forward. Drag occurs when an airplane encounters resistance. To be propelled forward, the plane must overcome this resistance. And then we have lift. Lift occurs when more pressure is exerted below the wing than above it, and this causes the wing to head upwards. The shape of the wing combines the air flowing above it and beneath it in certain ways to create lift. So we have these forces that you may want to talk about with your students. Now, it is interesting to notice that when we talk about helium balloons, which is what we're talking about here, or hot air balloons, same thing, there really is no thrust, because if you listen to that definition, thrust is being propelled forward, and this is not really, it's not propelling itself forward. You've got wind that's moving it, so really probably instead of thrust here we should have wind. So you might want to use this, but just keep in mind that the balloon is not actually creating its own thrust. So as you talk about that, you may want to figure out how to use that term better. Now, there are criteria and constraints that your students will be using as they do this lesson. You want to create a list of questions related to the problem. So we've talked about what the problem is that you want your balloon to float at a certain altitude or a certain height, either in the classroom or outdoors. And so you want your students to start, depending on their age, start thinking about how am I going to get it to stay there? What am I going to put on there? What will I do or create or add in order to keep it there? The students will be given materials, and we're going to talk about that in a moment. And the materials then will be the only materials that the students can use to change the level or to make this float at a certain level. So the materials are, for each group of 4, a Mylar balloon, some type of clock, because you probably want your students to come up with how long they would like the balloon to stay at a certain level. You've got small things such as paper clips, cooked rice, seeds, beads, other small objects, paper cups, string, and then the optional part that you can add on is thermometers and other sensors. So this is our last video we're going to watch today, and this is just going to tell some of the materials that you're going to see and gives just a little bit of a description. This is close to 2 minutes, and again, I will put this out the same way. I'll put it in the chat box and push it out on web chat. Hopefully you're able to see that. There was a video that just showed, so I know we just had some latecomers come in. But yes, we saw that gave you a quick overview of what your students are going to be doing and the materials. Now, students, I like to have students establish their own rules for this as a class. You will want them to decide what the suspension time is in order for it to qualify. Do they need to hang there for 10 seconds or a minute, or how long should they stay at this certain point that's been established? At what range of height does it need to be between 2 inches or a foot? What range of height would you like for them to be hanging at? So you might want students to establish this so that they feel like they have some ownership in it. You'll also want to probably break your groups up, have them identify the problem, identify constraints, select the design. And we're going to talk about the engineering design challenge in a moment. But I like to, as I break these students up, to give them different tasks. In the project engineer, they check on the team's work and ask the instructor or the teacher questions. You have the developmental engineer that will lead construction and makes the supply list. The facility engineer will direct cleanup and make sure to use only what is needed. And the test engineer records all information, fills out forms of any kind. So you just might want to give them tasks, and there are in the guides certain criteria, depending on your class, if you need to give them that specific of rules for what each team member does. There are some good rules for that in the guide. There also is a design packet. It looks like this. It is a second package that comes with this lesson, and it's designed just for the students. This is the cover, and the link is given on the NSTA page, the NES page, and this is just meant, like I said, for students. And even if you don't copy these pages, there are some, I'm going to show you, here's some pages, and it just gives you some questions and really helps the students to break out the different ideas. So we're going to talk about the design process here. This is a lot like the engineering design, or it is the engineering design process. So we're going to talk about what this is. Now, when students are given this problem, their challenge is to get a balloon to fly at a certain altitude for a given amount of time. So they're given the problem. Now they need to identify the problems. Well, one of the problems is that balloons want to take off. Helium balloons want to take off. They want to go as high as they can. We're going to have to do something to keep it at a certain height. We can't put too much on it. If you get a normal, typical balloon that you get at a store and tie something to it, that's too much. So the students may identify some problems. Then they'll start to identify constraints and criteria. Well, we have these list of materials. We could do these things, so they know what they have to work with. Then they'll start to brainstorm. They'll come up with different ideas that they can use. They might come up with several different ideas. Maybe each team member would come up with, well, we're going to put this cup and add this, or we're going to use this cup and add these. So they're going to be coming up with some ideas. Then they're going to select a design. So I think it's always very important for the students to brainstorm. I like to tell my students and my teachers that at NASA we have to spend a lot of time on the design, because if we were to begin building as soon as we came up with the first idea that came to mind, then we could waste a lot of money, because we could build something and it wouldn't work, possibly. Likely wouldn't work if we didn't go through a lot of tests, and then we would have wasted a lot of money and maybe injured people along the way. So we have to come up with tests and make sure that those ideas are good ideas before we actually build it, because building a lot of time takes money. So then they'll design and they'll build the model or prototype and see how that works. They'll test it. And then it may be good and they can share the solution. It may be something that they figure out it works, but maybe we could do this a little better, and they will rebuild or retest their prototype. And then this you see is a circle because it continues to be improved. And then eventually they'll get to a point where maybe they feel like they have the best solution for the design. And like I said, these sample pages help the students to get at these ideas. So even if you weren't going to photocopy these pages, you could write these on the board or have students answer these. And there are these certain steps: identifying the problem, identifying constraints, brainstorm, and select a design. So you'll notice that this is very similar. The engineering design process is very similar to what? Is it similar to anything else that you may teach in your classroom? Yep, the scientific method, good. Yes, it's very close to the scientific method. So this is something you probably could easily change over and just tell students that are, when you're teaching, maybe tell them a little about the scientific method and that engineers, or the engineering design process and the scientific method, that they're very close, and that engineers go through these steps every day. And you might even relate to this to something that they go through. They have problems that they solve, and they go through these certain steps also, and might not realize that they're solving their own problems in this way. Now, the next thing that you want to do is have them explore. So they will have come up with some brainstorm ideas, and like I said, I feel that those are very important. Give them lots of time to to brainstorm, and then they're going to select a design. And they will build that design and show that to you, and then build that. They'll build the model or prototype, they'll test that model, and again refine the design. So it goes back to the scientific method and something that you may want to test with them. Eventually they will have this floating at a certain height, and you may want to go back and talk about aerodynamic forces. When were they using lift? What about weight? How was the air in the classroom or outside affecting their design, or did it affect their design? What things worked? What things didn't work? So you can find, and at this time you may want to show those first two videos we saw about neutral buoyancy, and it talked about the astronauts in the neutral buoyancy lab, or and also the drag video on International Space Station. Those videos are officially part of this lesson, and you will want to show those also. And so you can find those. Let me give you the link. If you are part of the NASA Explore Schools, you will be able to get those from the NASA Explore School site. However, if you're not a member, then you may want to get these videos here. But these are what the videos are called, and if you go look on this website, this are a place you can just type these into a search engine, and you'll be able to find them that way. But there's lots of good videos here that relate to NASA and all kinds of topics. And there's different videos. The ones called Real World are for middle school age students, and the ones called Launchpad are ones for high school age students. And they have another one called, there's another set that are for elementary students. I can't remember what they're called, but they're all on the same page. So if you go to this page, you'll see lots of great videos, but you can look for these, just searching them in the search engine, or I just put the URLs in the chat box. You can look at them. But when you get to that page, you will have to search through, and I've put the thumbnails here, and this is what thumbnail image you would see when you get to that page. And so this one is the Real World, keeping the International Space Station in orbit, and this one is Fluid Dynamics, what a drag. So you may want to show those with your students also. Now something else, the link for the lesson plan, let me find that for you. If you're a member of the Explorer Schools, you can find that, but here is the lesson. If you can just get that from the nasa.gov site. And remember that all these lessons from nasa.gov are free for you to use. There are no copyright laws on them, so you can copy the pages as you would like. And yes, Our World, that's what they're called. The videos that I was talking about here before, Our World is the one for elementary, and there's some great ones on there too. Even as a middle school teacher, I would have shown some of those videos. All right, and so also in the back of that design packet that I was talking about, there is also some information about a rubric. So I always think it's very good to give students an idea of what they're going to be graded on. And the rubric is given in the back of the student design packet, and it lets students know ahead of time of what they'll be graded on. So here's some of the topics here: brainstorming, generating ideas, how they build their model, how they test their model and evaluate it, how they refine the design, and share the design. And I think the great thing about this type lesson is that there's not a right or wrong answer. Students are allowed to experiment and find out what works for them, and they begin to realize that sometimes there is more than one answer that is correct or works. So So, and I put that lesson, if you look under Real World, the link that I gave you to the lesson, if you look under Real World, that's where you'll find this lesson. Okay, now I've been talking a lot. How many of you, what kinds of questions do you have about this lesson? There is a lesson, there should be when you go, if you're part of the Explorer Schools, there's always a teacher resource that does have a PowerPoint that you can use with your students. So you can look under, when you go to this site, you can look under resources, I think it's the teacher resources, and you should be able to find a PowerPoint, not this exact one, but one that's very similar that you could use in your classroom. And I'll see if I can find that. Do you have them calculate the mass needed? And that would be a good thing. Maybe have them calculate the mass that they've found. That's a good extension activity if you're talking about mass and different scientific topics. Yeah, that would be a great one to add in there. How much mass did they use? Maybe looking at the size of their balloon. How much did they use? Did other students use the same? Did they use different size cups? There would be a lot of different variables you could use there. Inside or outside, I would say it really depends on your students. I would hate for the balloons to get away, so I almost would do it inside until your students maybe have them weighted properly, or you know, figure out how they could stay in one place best. It would be really good maybe to start in your classroom where you have a lower ceiling, and then if you have a certain place in your building that maybe has a two-story building or two stories high, that would be a good place to practice it. If you could put really long, very long strings on it, that would be helpful too. So I would do that first before going outside. And of course, you have to contend with weather. If it's going to be too windy or rainy or whatever, outdoors is not going to work either. Is helium still available? Huh. Well, I just got a helium balloon filled this weekend, so it is here. It may be not in some areas. What are Explorer teachers that you reference periodically? And I'm going to tell you about Explorer Schools later. But NASA Explorer Schools is a place that teachers can come to our website and learn more about NASA activities and NASA lessons, and we teach you how to use these lessons in your classroom. And so I'm going to tell you more about that and how to get involved with our program. It's a really great program for teachers grades 4 through 12. What materials would students use to build their models? Would you mean twice as many balloons? Well, let me go back to the materials slide I had back here and talk about this for a minute. These are the materials that you'll need, and I would put students, depending on the grade, I always like to do groups of 3, but 2, 3, or 4 works well, and you're going to give them probably a Mylar helium balloon would work best, and then you could use that same balloon class after class if you have multiple classes in a row. And then you're going to give them the option to use these different things. You'll want to give them a paper cup. You may want to offer them different size paper cups and let that be one of the choices. You'll give them some string that will be already tied to the balloon. And then they're going to have to decide how they're going to put this all together and what kinds of materials they will need in order to keep this hanging at a certain spot for a given amount of time. So really, they're going to need, the majority of the things that the students will need, this question refers to, is you're just going to give them a paper cup, and you might want to offer them various sizes or something else that could hold materials, and also these small objects that they could put in the cup. Would you need twice as many balloons? I think you could reuse the balloons from class to class as long as the string isn't damaged. Is there a place you can go to get the guides in hard copy? You can print this out, but there's a place called an Educator Resource Center. There's generally one in every state, and usually can go and get them there. So you could look up on the website how to find one there. But generally the best thing is going to be just to print it out. Oh yeah, a stairwell would be a good place to practice this too. You'd have some good height there. Okay, I'm reading through the questions. Could they also measure and label string length, then chart adjustments in mass and height for the string? And that's a good one, because the string is going to add a little bit of mass to it and a little bit of pull to it. So yeah, that's going to be something else that you could use. That's a good modification. Okay, and then we get into hobbyists, balloon hobbyists doing high altitudes with cameras and balloons, and that's what the video that we saw earlier, that's basically what NASA is doing, is they're taking these weather balloons and taking them up into the atmosphere and studying either things about the atmosphere or things about outer space. And so that could be a good thing for you to test, and that's what we're going to talk about next. Why not tie it to a good balance on your desk? Oh yeah, you could test the mass. All right. So I don't see any other questions coming. So I'm going to go on, and we're going to talk about extensions a little bit. So we talked about that what NASA does with these weather balloons is they attach something to it, and you see this image. There's a sensor attached to this, and they take it up into the atmosphere and study various things about the atmosphere, or maybe they can take better pictures of things in outer space because they don't have as much of the atmosphere in the way. So you'll want to tell students about that. You might want to show them the YouTube video that we saw earlier. And then you'll want to, if you have time, and depending on the age of your students, you may want to have them attach some kind of sensor to their balloon and make it float at that certain height. You could use a thermometer and measure temperature, a hygrometer and measure relative humidity, a barometer that measures air pressure, an altimeter that measures altitude, solar irradiance or radiation. You can study those things. And again, it may not be very different, especially if you're doing this in your classroom. The temperature of the top of the classroom versus the ground of the classroom may not be different. But the important thing is to share with them the ideas that these are some of the things that NASA is doing, some things that go on in the real world, because we're trying to convince students that science is fun and some of the potential careers that they could go into. So it's important to share with them the kinds of things that science is doing, and that this is a simulation of what is actually occurring outside of your classroom walls. Now, one of the things I really like to do with students is to create a storyboard poster, and this will a lot of times bring in your students that really like science or they're good in writing, and they create a storyboard that will document the evolution of their design. And so you can, in any search engine, type in storyboard, and it'll come up with various ones that you could use. And so here you could have the students draw pictures of what they started with. You could have them write ideas about what they came up with, some of the initial questions they had, some of their designs, what worked, what failed, how they changed some of the features, and then their final design. What did they come up with? And this is a good way for you to see what their brainstorming ideas were, what kinds of things they came up with. And it also makes them document what they're doing. And it's also a good way for you, if you're going to have your students do presentations, they also can use this as their presentation. So it makes them write down and think about the types of things that they have studied as they have gone through this lesson. All right, so do you have other extension ideas that you could use with this lesson? Okay, using an aerial cam for a football or basketball game, that would be good. Good idea. Okay, send up a balloon with a video cam. Yeah, with a long string so you can get it back. That's a good idea. Okay, and students could think that's a lot of fun. They could study various things as you send those up with a long string to get those back and just see different images. All right. Well, before we leave, I'm going to tell you about NASA Explorer Schools. I'm going to show you this short video. This is just about a minute and a half, and I'm going to just let you see what some of the students did with their designs. So we'll watch this, and hopefully many of you can see this. Okay, so hopefully you were able to see that and just kind of showed what some of the students had done with their design. And again, in that one you saw that the teacher actually told them what to do, that you need to put your cup at a certain place. And you may, if you have younger students, you may want to tell them that, but with an older student, I would have them, that's going to be part of what they're going to have to figure out. That's part of the engineering design challenge of this. So I would not necessarily tell them those, depending on the age of your students and the ability of your students. And there is a place that you can get the NASA Mylar balloons, and somebody before in one of the previous classes had put a link in, so if anybody knows that, but you might just want to type in the chat box Mylar balloons, or you might want to contact CORE. CORE is, you could find that on the NASA site, Central Operations of Resources for Educators, and they sell things at a very inexpensive price to teachers. So you might want to check with them too, and you could find that on the NASA website. All right. I think we've gotten a lot of questions out of the way, but does anyone have questions? Okay, well, if you have any other questions, then let me know, and we'll have some time at the end to chat too. So now I'm going to tell you about NASA Explorer Schools. Some of you had asked what this was, and I'm going to tell you now. So if you will, you can put on the chat box if you are part of the NASA Explorer Schools or not. And I'll go ahead and tell you, as y'all are checking in, who is eligible and who is potentially eligible for this. This is aimed at teachers that teach grades 4 through 12, any of those grades in between, in a classroom in an accredited school that's a certified teacher. If you fall into some of those categories but not all, we do have something called special access. So maybe if you are a pre-service teacher and so you're teaching college-age students that are become teachers, or you work in a museum, or you're a homeschool parent, there's some of you that can get access to the program, and you can look at all of our materials. But we also have programs that teachers can do. So normally teachers can apply for opportunities, but if you're on the special access, then you'll get access to our materials, but not our special opportunities. But if you go to this website, it's called exploreschools.nasa.gov, and if you're already a member, you will sign in here. If you want to register, then you will sign in here. So you either sign in or sign up. And this just kind of tells you an overview of who we are and what we do. There's some videos here that will tell you how to use our program. Okay, so if you sign in here, then it'll take you to a page. You'll sign in, and then you'll go, after that, you'll click on this page. And if you're looking for this lesson that we just talked about, you'll click on this called Lesson Library. Let me tell you about some of the other things we have here also. We have these things called NASA Nows, which are videos that are about 5 minutes long, and we highlight a NASA career. Every week we put a new one up, and they're filmed and put online for you to use, and they're archived. So you can talk to your students about different NASA careers that are out there to encourage them to go into these STEM fields: science, technology, engineering, and mathematics. So that's a great thing. We also have these things called web chats, where we have some subject matter experts come in and talk to the students live online, and the students can type in questions for the subject matter expert to answer live online. So those are some things that we do. But the lesson library is the main thing we're going to look at right now. So the lesson library is all of our different lessons, and I think we have about 40 right now that are available for you to use. And again, you'll see here there's some videos of tutorials of how to use our program. So you'll get to a page. After you go to Lesson Library, you'll look at a page that looks very similar to this. And you can either search for a particular lesson, or what I like to do is browse all lessons. So you'll click Browse All Lessons here, and it will take you to a page, and you'll look through there, and you can find the lesson that's called Engineering Design Forces in Motion Balloon Aerodynamic Challenge. The guide is listed right here, so those of you that are part of NASA Explore Schools, you know how to get to the guide. And remember, I told you that there was a design packet. The design packet is listed here also. So that's a PDF, and it will come up, and you can download that also. Now you see this lesson gives you a description of what we're talking about here, gives you topics that are going to be covered, grade level, instructions. Under each one of these here, and also these over here, you can click and find more. You can find the national standards. You can find the materials you'll need. You can find some links of how this connects to NASA, to other things that may be used here. Some more extension activities that you may want to do. I just told you about the NASA Nows, which are the highlights of different NASA careers. It's a 5-minute video about someone's career and what they do at NASA. So there may be one that's related to this topic that you may want to share with your students. If you would like to attend another one of these classes, or you find someone that from your class that may want to attend this, one of your other teachers from your school, they could attend here. Or there's also videos that is very similar to what I've taught you tonight. And so teachers can click on those videos and get an idea of what this lesson is about, watching about five-minute videos, or in about 30 minutes they could watch the videos and find out how this works. Also, many of the videos that I have shown you tonight are located at this video collection, so you can click there. Now, as you become a part of our program, you can earn recognition. You can bring students to a NASA center, or you as a teacher can get an expense-paid trip to a NASA center in the summer. And so there's certain things you need to do, but after you have watched these videos or taught this lesson, you'll need to take these surveys. So those of you that are Explore School teachers now know that you can take this lesson survey, and that will give you credit for attending this class tonight. Now, I was telling about the video collection. Here are the videos, and you can watch these videos. Like I said, here's the introduction, the lesson in detail, classroom instruction, and so it just tells you how to do this lesson in your classroom. So you can watch these here, or show this to another teacher in your class, in your school. Now, if you're interested in becoming, learning more about NASA Explore Schools and finding out more every day what we're doing, you can join us on Facebook. It's NASA Explore Schools page. You also can follow us on Twitter, and here is our hashtag. Now, there is a specific page that is just for this class, and I have put a couple of videos there, and I put teacher stories sometimes. And so here is a website for Facebook that you can join that page and like that page. And after you've taught this lesson, if you want to share with other teachers how the lesson went, what the students liked, how it went in your classroom, what you liked about it, you can share those things on this Facebook page. And so other teachers can get to this page, and I post videos, like I said, that you may want to show your students as you're teaching this lesson. So I'd encourage you to go to that Facebook page and like that page, and get to know some other teachers that may be teaching that lesson from this area. There also is a page called Neon NASA Educators Online Network. For those of you that might not be on Facebook, you can go to this page, join NASA Explore Schools, and then go to the forum, and there should be a forum on this lesson, and you can find out some about that. So if you are an Explorer teacher, we are going to take a survey for NSTA, but make sure that you go back to the NES website and take that survey too. You'll need to do both in order to get your credit. Now, I see a couple questions. Are the materials that are provided extended physics of balloon aerodynamics, real aerodynamics? What happens when they elevate? Do they change shape? I guess it could be part of balloon aerodynamics. So it's a smaller scale, of course, you're not going as high, but it would be very similar to what real ballooning aerodynamics. A little bit different because it is a mylar balloon, not a hot air balloon. But you could add that in. That would be a great idea. Okay. Well, thanks for participating today, and Vanessa has some more information for you, but here's my email address. If you have questions of me or need any of the information that I've provided this evening, I would be glad to give that out. And so here is my email, and please contact me if you need me. Okay, and I'm going to turn it back over to Vanessa.
Thank you so much, Kristy. That was really fantastic. Let's go ahead and give her a big round of applause. Remember, your emoticon is the first button under your name, and you'll see an applause button. If you could give her a big round of applause. Thank you so much, everybody, for helping us with that, and we do really appreciate, Kristy, your time this evening. We'd also like to thank NASA for sponsoring the web seminar this evening. We want to also remind you to visit us in the Learning Center, your EPD portal with over 6,000 resources for teachers and the place to register for future web seminars. We also want to thank the platform providers at Blackboard Collaborate. As always, we'd like to thank the administration of NSTA for their support of our web seminars. We'd also like to remind you of some upcoming web seminars that we would love to have you join us. Our next NES will be Vector Addition, Math and Science at Work, Lunar Surface Instrumentation. On March 12th, we'll have NASA K-12, The Search for Other Earths. And on March 13th, another NES Engineering Design Challenge, Water Filtration.